Hello everyone, welcome back to my channel. And in today's video we are going to deploy multiple microservices onto a cluster. So this project is going to be end-to-end. Like firstly we will deploy onto the Docker, then we will uh, orchestrate this application onto EKS cluster, and then we will be creating Helm chart for these kind of application deployment. So here the main thing will be we need to focus on the microservices deployment. So in various project of, if you have seen in my channel, those contains the deployment part. Like once we have the application, how the deployment is going to happen. There are certain various Jenkins stages has been declared that takes care of it. But today, if you join any organization at this moment, so this is going to be a very interview specific thing, like how today you will have the better understanding of how the microservices interact with each other when we deploy onto Docker or any cluster. Also I will try to give you a walkthrough of from the coding perspective as well, like what part we need to see in order to see the interconnection of this application at the coding level, right? So you can see here we are using how many microservices. We will have 6 microservices. One we have for user interface. This is the one where the external user will be accessing, right? And there will be one API gateway that we are using to uh, divert the traffic to our next 4 API application. Those are basically API. So whenever we will try to hit the API using the UI is nothing but the front end page. We are going to get some output with the respective 4 APIs. So let's go here. So these are the 4 microservices we have. Those are SUS, offers, cart, and wish list. So this is a kind of e-commerce web portal, right? And this is the UI where user will see the actual page, which they will land on this actual front end page. And then this is the API gateway, which takes the request from the UI and uh, divert the traffic or transfer the traffic to the particular microservices which is requested, the user has requested. Apart from that, the tech stack used here are, we have React.js, we have Springbot, we have Python, and we have Nodejs, right? So let's go to the PPT, and let me try to give you a walkthrough of this. So this is the UI which is been written, where we have used React.js for the implementation that runs on 8080. And this is the Joule API gateway, as I told, based on the request from the front end done. The Joule API gateway will revert the traffic or divert the traffic to the respective microservices, and the Joule API will run on for a trip of 9999, right? And then we have 4 microservices whose, that is basically the tech stack which is used here, that is Spring Boot, which will run on 1002, right? And apart from that, sorry for that, apart from that we have offers that will run on 1001 port, and this is also written and codified in Spring Boot. Apart from that, we have cart that is written into Nodejs. The tech stack is Nodejs here, which runs on 1004 port, and at the end we have wishlist that is written in Python, and the port which we need to open here is 1003. Correct. So this is the kind of microservices architecture you will have in your organization, if you're right. And this is just an example. In the real time you will have 100 plus thousand of microservices running, but the key point here, the working principle is going to remain same. If you will learn this, then that is enough. Okay, so let's get started with the coding walkthrough. So here I have cloned the code into my local. I will place the link in the YouTube video description. You can check this out and you can try to implement, guys. So you can see we have the cart, we have the offer, SUS, UI, wishlist, Zool API, gateway. These are the code we have. So basically the first thing is how the interconnection is happening. For that you have to check this UI web app React.js. If you will go to the source, if you will go to the components, you have this app.js, right? And here this is what your front end is. So basically one thing what you have to do, uh, whatever server you are hosting this application, on which server you are hosting this application, you have to place the IP address of that server. Okay, here that thing you need to do. And once let me show you more on this how the API gateway works. So you have to go to this rule API gateway, go to the source, go to the main, go to the resources, and take this application.yaml. So here let me brief you about the function. So here you will see this is the server IP, the front end IP. Okay, front end IP means the server on which you are going to host this application. That will be a EC2 instance. So you can use the public IP of that, and this is the port of the this your API gateway, right? Let's see. This is the UI which you will be accessing. But to hit this API gateway, you have to use this port, right? So that is what you will see in the code. It is having triple nine plus one more nine, right? And here you will see e dot target name is there, right? What does that mean? If you will see here, there are various microservices. Like on the application there are various buttons are nothing but the form, right? Whenever you try to submit any form, you see there are a couple of buttons, right? So you will see here the name of the button is SUS/SUS, offers cart wish list, correct? And when you will try to click on this button, it is going to handle API call. So this button will contain the value of this SUS/SUS, correct? And this is the value which we are going to pass here. So IP address of the server, then this is the SUL API gateway slash su. If you have given this suppose cart, what will happen here? It will have the plus slash cart is where this, right? And it will go to this particular docker container. Okay, so we will have multiple docker container also, guys. So let me make it more clear. We will have 1 2 3 4 5 6 docker container, means 6 microservices we have containerized. Okay, and all the docker container have uh, these port open, means exposed, correct? So here you can see the IP addresses are same because all are running on the same EC2 instance, means the server, but the IP address is the main key which is transferring the traffic to the correct part, Docker part. In the same way, if you are clicking on the west list, what will happen? This is the button. When you have clicked on click, this is going to this call this function handle API call. It will come here, handle API call. It will have the URL like this. What is the value we will have here? Plus wish list, right? The name of the button, the value slash wish list will come here, correct? And if by coming here, what it will see, the URL will go to the 1003 port, isn't it? The same port for wishlist, right? So make sure if you are creating the Docker container, the correct number of pod should be opened, right? So let's do one thing. Let's get started with the lab now. So what is the first thing we have to do? Let's just go ahead and create a EC2 instance on which we are going to host our application. So click on launch instances. So this is the basic thing. I hope you are aware. If you don't know, let's do a so I will name it microservices. I will choose Ubuntu, and then let's choose T2 medium server. And then if you don't have key pair, just create a key pair. I have it, so I will select mine one. Then coming to the networking setting, right now I will do what, I will open all the port. So I will choose all traffic anywhere, right? You can increase the volume if you want, but I don't need it, so I will launch this instance now. So let's wait once this instance is up. So what is the minimum prerequisite here is you have to install Docker. That's it. Docker on the server means the EC2. So let's see, it is still in the pending. So let's wait until the status check is going to be true. So now what we can do until the server comes up, let's do one thing. So let's do one thing. Let's start with dockerizing the application. So what is the first thing which we are going to dockerize according to the PPT? You can see. So this is going to be a UI. This is a React.js application. So for that I am going to write the Docker file. So let's go to the code, and this is the UI. We don't have any Docker file here. Let's try to add a Docker file. All right. So for the React.js, what is the image we do use? That is Node. And here for this, I'm going to use Node 8 as a base image, right? And here I'm going to define the work directory. That will be /app. Okay, work directory is what? Work directory is nothing but whenever you will try to exact to the container, this is the first root directory which will open. Now what are we are going to do? We are going to use copy to copy the code from current directory to the work directory, and now we are going to compile this code. So what is that command for that? That is npm install, since it is a React.js. npm install, and then what is the port which we are going to expose? So expose doesn't expose basically onto the Docker side, but this is the port while writing the Docker file we mentioned, so that whenever we are creating a container sorry, a person will expose this port, so they would be aware like this is the port I have to open to access this application. Now we have to make this container executable, so that is a simple command npm start. So these are the Docker file. Just try to remember, guys, because this is what in good product based company they are going to directly ask you to write a Docker file to Docker file for React.js application, Springbot application, Python application, right? So this is basic thing you should know. So we have written the first Docker file. Now let's see if this is up. So we can see this, the status check is 2 by 2. Now we will try to connect. So what we can do, we can make use of the SSH client because I do not have putty installed. So if you should have this key onto your local, just copy this, go to I have this in download, I guess. So I have this, right? What I will do, I will open CMD here. I have the key here. By just executing this command, I would be able to SSH to this server. Okay, so add the fingerprint. So now we are into the server. So first thing what we will do, we will try to update the packages. Update. This is the first thing you have to, whenever you log into EC2, you just have to patch the server with the latest package updates. So let's wait until this is done. So once this is done, what is the minimal prerequisite we have to do? As I told, I have to install Docker. So you can refer to my this uh, GitHub account, and here you have to search for install this installation script. People 840 people have forked it. This is very useful, guys. It have all the installation command. You can copy this the command from there. Let's go to the server. We have done SSH, so let's try to create a simple file, docker.sh, and I have pasted, and let's run this. Either you can run by chmod by making this file executable, chmod plus x in this file, or you can directly use sh and then enter. It will run the Docker. All right, let's wait until this is been installed, and we will try to check the Docker is up and running or not. Great. So now let's check if the Docker has been installed properly on the system or not. You just have to do Docker info, and we are getting this output, means the Docker is up, right? Another thing you have to do is what I told in the beginning of the video. You have to take the public IP address of the server on which you are going to host this application. So let's copy the IP, go back to the code, and first the change you have to do is in this UI, source, components, app.jsx, and here just replace with this existing IP. Port is going to be same as per the diagram I have showed you in the Excel PPT. And another thing is where we have to change in the API gateway, which is responsible for uh, transferring the traffics. So you have to go to the main resources and this application.yaml, and here everywhere you have to replace the IP. Okay, that's it. So this is the minimal change you have to do, guys. Now what we have to do, we have to write Docker file for each and every microservices. So for one UI React.js application we have already written. Now we will write for this Zool API gateway, that is the tech stack is Springboot here. So we will try to write a multi-stage Docker file in this case. So let's open this Zool API gateway, and I will try to create a Docker file here as well. All right. So what is the base image I will use? The base image we have to use because Maven is not installed in my system. So that is why I am writing this multi-stage Docker file. So So the base image will be Maven, right? I am not giving any version, so it will take the latest Maven to compile the code, and I am doing aliasing so that okay. And now define the work directory, guys. Work directory slash app again. Now what I'm going to do, I'm going to copy dot and dot is nothing but the work directory, like this, slash app, the second one. Now what you are going to do, you are going to run what mvn install. This will create the dot target directory, which will have the dot jar file, right? So what is the name of the jar file it is going to create? So this is one of the interview question, important interview question. Let me tell you first. Let me write the docker file, and then again I'm going to use a base image here. This time we need a openjdk. So right now I'm going to use openjdk 11 for that. Okay, and then let's set the work directory slash app, and then what we have to do, we are going to copy from stage. From which stage? The one which we have up, that is build. What we are going to copy? We are going to copy the jar file. So where will the jar file reside? Into the workspace directory. It will have a target folder. Inside that target folder, what is the name of the jar file it will create? So for that you have to go to pom.xml. So this is the job of the DevOps engineer as well. So know to know. Basically you will get this name from the developer, but you can get it from your own. So this is the artifact ID you have to take. So the name is Zool, and then you will have this version. Okay, and then we are not defining any extension, so it will create basically by default a jar file, and that we will copy where? We will copy into the uh, here, correct? And then what we will do, we have to expose this. At which port we are going to expose this? Trip uh, 1234 double nine double nine. And then once this is up, we have to run it as executable. How do we run it? Java-jar, right? And the jar file name, jar or var. And what is the name of the jar we have? We can copy from up. Okay, paste. So this is done, guys, right? Now we have written for two of them. Again, now I am going to write for the source. So again, let's go to the source folder. Source folder, let's create a docker file here also. Docker file, and here this is a kind of also Springboot application, right? So as per the diagram you will see it is a Springboot. It is using tech stack as Springboot, SUSE and offer both. So let's write multi-stage docker file for this also. From maven as build. This is the alias name which I am using. Why this is not true? Okay, and then what is the work directory name we have? Work directory is plus app we use, and then we will use copy what? Source to the all the code from source to the destination. And then what is the port, what is the command we need to run? Maven correct? And then you will write from base image. Again we will use the same what we have used earlier, openjdk 11.0.10 hyphen JRE. You will get this from the Docker Hub because I have written several times. I know the application compatibility, so that is why I'm using this. What is the work directory we will have? Again slash app. What is the next thing you have to do? You have to copy, correct? From where? From build. What is thing you have to copy? You have to copy from app. App will have target directory. Target directory will have what? What is the jar file? It will have target directory will have source slash snapshot dot jar, and that we have to copy to the jar. We have to copy to this directory, work directory, and then we have to expose this. We have to expose this to which port? We have to expose this to 10002, right? And then we have to run this application, that is cmds. What is the command of that? Java hyphen jar, and then the artifact name. What is the name? This is the name we will take, correct? Right. And once this is done, we are done with the writing the docker file of source. Now we will do what? We will try to write the docker file for offers as well. That is going to be similar. So let's go to the offer section again. Let's go to the offer section again. Let's create a docker file here. Docker file. And again we will write, this is a kind of Springbot, so we will use maven as build, maven as build, and then work directory is going to be slash app, and then we will copy the source file to the destination, whatever we have in the code. So what we will do, we will run mvn install, right? And then again we will have from openjdk 11.0.10 hyphen jre, and then here what we will do, we will set the work directory which will be slash app, and then we have to copy the target, the jar file from the previous stage to this stage. That is why it is called multi-stage docker file, right? From build, build is nothing but the name of this, the alias of the first stage, build. What we will copy everything from slash app target. What is the file name we have to copy? We have to copy offers hyphen, let's check the pom.xml. This is the snapshot version we have. This is the name of the jar file basically it creates, so that is why we know. Then copy this to this. Now what is the next thing? We have to expose this. At what port this offers microservices is getting exposed? That is 1001. 1001. So let's go back 1001. Now here, now we have to run this application. So this is the last Spring Boot application microservice we have. Java hyphen jar, and then the name of this. So we are done with this as well. So now the remaining microservices are cart and wishlist. The cart is a Node.js application and the wishlist is the Python application, right? So let's go ahead and let's create a Docker file for this cart. So let's go back to the code cart, and here I will create a Docker file. So this is a Node.js application. We will write a Docker file for Node.js application. So the base image will be node 14. I will set the work directory as /app. Now we will copy from local to the work directory. Now I will run the command npm install, and then we will expose this. What is the port we are going to expose this cart microservice? The cart microservices will be exposed at 1004. Let's mention here, and then we have to run this. So to run this, it is also very simple. Node and index.js, index.js. So this is how it will execute. So now the last service we have remaining, that is wishlist, and wishlist is a Python application. So let's go ahead and write a Docker file for this Python application. Cart is done. Let's go to the wishlist. This is the wishlist, and here I'm going to write a Docker file for this. And here the base image will be Python 3, and we will copy the code from source to the destination, and here we will run. To run this, we need what? We need these dependencies. We need pip install, we need Flask, and we need Flask course. These two things we need in order to run this application. And then we are going to expose this. We are going to expose this at port number 1003, correct? And then we will execute this using Python, and then index.py file. So we are ready with the Docker file writing of these all application, right? Now what we are going to do, we are going to run this all application onto a node, right? That is a basically a EC2 instance on which Docker is running. So let's see if this is still up. No. Let's start that again. Let's go to the connect SSH client, click on this, go to downloads where my file is cmd. Let's Once you are here, just do sudo su, and first thing we have to do, whatever changes we have made, that we have to push, right? That we have to push. So what I will do, I will try to push this. We can push it through the VS Code itself. Git add, git commit, added, add something meaningful to your commits, add a Docker file, git push origin, and the name of the branch is main. Okay, there is a typo. So our code is pushed to the repository. Let's go to the directory. Okay, So here we have our code. Let's clone it. Go to the server, git clone, and this we have our code here. If you will do ls, it will go microservices docker. We have all of our microservices code here, correct? Now what we will do, we will try to create images for all the things, right? So let's go to first, let's start with the UI, right? What is the UI? UI is the react.js at port 8080. So go back to here, go back to the UI code. What is the command to create an image? Docker build hyphen t UI, and the docker file is present in the current directory. So let's wait until this is being compiled. So first we will try to create images of all the microservices. Then what we will do, we will try to containerize it. Alright, so right now npm install is running. It will take some time. So guys, we got our first image, docker images, and we have our first image now. In the same way, let's try to build another microservices we have. Let's now compile the second, the Zool API gateway. Let's go to the Zool API gateway and docker build hyphen t Zool API dot. So we are building our second. We are building image of our second microservices. So this is how you work in the real time. So these all things should be automated using Jenkins. So that is a very easy step, right? We will see that as well. Just comment down if you need that. So still build is running of the multi-stage docker file. It's downloading all the artifact and dependency. We can see the build is succeed and we have it now. So now we are going to run the third microservices, that is SUSE, correct? So let's go back to the folder SUSE docker hyphen t SUSE dot. So now we are building SUSE microservices. Okay, so this is also done. Now we are going to build the fourth microservices, that is offered. So let's switch to offers directory, docker build hyphen t offers dot. So similarly we have to build the two more microservices. Let's do that. So now we have a Nodejs and one Python application. Ready? So this is also done. Now we will build the cart. Let's switch to the cart directory, docker build hyphen t carts dot. The cart Cards application is a Nodejs based application. The tech stack is Nodejs. So this is also done. Now we are left with the last application, that is wishlist, right? That is wishlist, Python based. Let's switch to that directory. Docker build -t list dot. So now once we will have all the images here, we will now try to containerize it, dockerize it. Okay, so we will try to create various container and we will try to run our application, right? So this is throwing some error. Maybe you want to install. So I have written the wrong spelling here, you can see. So let's do one thing. Let's edit the Docker file. We are in the same directory, correct? Pip install. Let's build it again. So since Docker works on a what we can say layered by layered, so you can see it has already run all the layers. So it's when I have ran for the next time, it started with the the layer 3. Okay, now let's list our all the images, Docker images. So we are having all of our microservices, 1 2 3 4 5 6 microservices image we have. Now we will try to containerize it, right? So what is the first command we have for running a Docker container? That is docker run. We will try to run it into the daemon mode -d -p. What is the port on which this UI, this is the first UI which we will try to expose. This is running on 8080, right? So let's go back, let's expose the 8080. Port mapping is done. Now what is the image I want to use here? That is UI. Hit enter. All right, now type docker ps to list out the running container. So this is the container ID for the image UI and it is being exposed onto this, and the name we got something like laughing cage. Nice. So let's try to access this. So what is the port of our application we have? What is the port? Sorry, what is the IP? So this is the IP, right? So this is the IP and it is running on 8080, right? So let's see if the application loads. So this is the application, this is the web application we have hosted today, right? So it is running on 8080 port. This is going to be our front end that we have seen, and these are the microservices which we have clubbed, right? So the main focus here was the interconnection between those all Docker containers. So in the real time also the scenario is going to be almost same. So don't worry about that. Just focus on the structure and the interdependencies, correct? And the kind of deployment which we are doing here. So right now these all won't work because these all are not active right now, correct? So after the UI you can see API gateway hit. So we need to deploy the API gateway as well, right? So right now we have just one Docker container running. Let's try to run the another one. Docker run -d -p. At what port the API gateway is running? 9999, right? Map to what is the image we have? This is the image we have. Run it. So something wrong with this executable file not found in the path. Let me go back to the Zool API directory because this is very important, right? In order to run this, so here basically we are copying the build from Zool API gateway. We're using, what is the error we have? OCI runtime creator unable to start container process java -jar Zool snapshot app. We have written the right version as well. What can be the issue? Java jar, or C. This is the mistake we have done here. So we have to edit the docker file again. Docker file, it will be java -jar, right? So we are what we are, we can see the troubleshooting as well here. So this session is more meaningful to you, right? So what we have to do now, we have to remove one images. Docker image ls, the image is images, docker rmi, and this image is not correct, delete it. Okay, let's see docker ps hyphen a. Let's delete this docker rm. We have to delete this container, correct? Because this container will have the port occupied, right? So we need to delete it. Once this is done, we will try to create a docker image. Docker build hyphen t. What is the name? Zool API dot. So let's wait till this is being compiled. So it is building the image again, and then we will try to create the container based on that docker container. So build is successful. Now we have it. Let's try to run the command again. Docker images. We have the new Zool API image. Now let's try to run a container. Docker run -d. Let's do the port mapping 9999 9999, and then the image name API, enter. So now if you will do docker ps, it will show you all the running containers. So now this is also running, it is in also running state up till from 3 seconds, correct? So now when you will go back to the UI and you will try to hit this, it won't do anything, right? It won't do anything. Why? Because right now your microservices are not up. These 4 microservices should be up in order to make the request to the from the API, right? According to the diagram, from the UI means from this page you are clicking this shoes. So what will happen when you will click on that shoes from the Zool API gateway? It will go to the particular microservice that I have already explained you through the code. So you can go back and see that if you have any doubt, because this is very important. So now let's try to deploy all the other microservices as well. So now what I will do, let's go back here. Docker run, I will run the SUSE container now. -d -p, it is running on 1002 1002. What is the image name? SUSE, right? So now do docker ps. So we have our another container running. Let's go back to the UI and let's try to hit on this shoes microservices. So from the UI, the response will go to the API gateway, and from the API gateway the request will go to the particular microservices. Let's hit on the shoes. See, we are getting some response from the from that particular microservices now. So earlier when it was not deployed, we were getting some error. Like you can see by clicking on the offers, you can see microservices down, microservices down, microservices down. Means the health check is failing. The particular uh, microservice is not up. But in case of shoes, we have it running. So let's go ahead and let's just deploy the next container, that is offers. So docker run -d -p, and the port we are going to expose, that is 101 1001, and offers, and then images offers, right? Docker ps. So offers container is up and running. Let's go back and let's try to hit this. So now on Samsung you have 100% discount, on Adidas shoes you have 70% off, and Nike shoe you have 50% off. So this is the kind of responses we are getting from the respective microservices. Now we have two left, cart and wish list. Let's go ahead and deploy those two also. So docker run -d -p. The cart have 1004 open, and the name of the image is carts. Docker ps. Let's try to hit on this cart. So we have got the response, right, from the shoes, from the offers, from the cart, and only the remaining is now this wish list, right? Let's go ahead and deploy that as well. Docker run -d -p. Port is 1003. What is the name of the image we have? That is wish list, right? All done. Docker ps. So we have all of our container up and running, right? So now the complete application has been deployed. Shoes, offer, cart, and wish list. Okay, there is some issue with the wish list, guys. In that case, let me check the code of this Python. So let's go to the wish list index.py, and here we do define the host. uh, so right now you can see the host is defined as nothing, so it is using 5000 port as by default. So for Python we have 5000 port exposed, right? But here the host is 0.0, so it has taken by default 5000 port. So what we have to do, we have to recreate the container. So let's go back and delete and recreate the container at 5000. Docker rm, what is the container id for this list? This -f. So it's been deleted. Now let's try to create another. Docker images, docker container, sorry, docker run -d -p. Port is 1003, right? 1003, but the port will be 5000, right? And the image is wish list. Now do docker ps. Now it should be up and running, because in the command also we can see it came up. Let's see wish list. So now you can see, right? So this is how you got the end-to-end microservices deployed. So the same thing you can use, you can deploy using the Jenkins file. I have gone through this way because I wanted to go for the step-by-step deployment. So once you are done with this step by step deployment. Basically, you can easily go to the Jenkins and you can write a declarative pipeline for this automation, right? So if you want me to create end-to-end deployment for this as well, you can comment below. Okay, if you are having any kind of doubt, just drop down into the comment. I will try to respond as soon as possible. You can also reach out to me via LinkedIn, and you can ask your doubt there as well if you have something urgent. So this is how a microservices based architecture will be deployed onto any organization, right? There can be thousand, hundred of microservices that needs to be deployed in a similar fashion, right? So that is all for today. Thanks for watching. Please do like, subscribe, and comment, and share with your friends.